If your AI agents or AI products feel a bit clumsy today, just give it 12 to 24 months and they will feel like magic. Scaling laws explain exactly why. And without understanding scaling laws, we risk building products that get crashed, outdated, or simply left behind. In this video, we're going to uncover the blueprint behind AI's relentless improvement. We will see 3 very powerful assumptions that we must consider when we are building AI products, and why knowing these dynamics is not optional anymore if you want to survive and thrive. But first, what are exactly scaling laws and why do they matter so much? Well, scaling laws are brutally simple, but also very powerful. They describe how AI performance predictably improves when you increase one of the 3 key levers. The first is model size, which is the number of parameters inside the model. The second is data size, which is the number of training examples and is measured in the tokens. And then the third is compute, so the amount of processing power or flops that the model can have. But the important part is that all of these is not random. The relationships between these 3 follows the power laws. So for example, if you double the compute, you predictably get consistent improvements in the AI. And this is why scaling up reliably can make AI smarter without the need of brand new and amazing algorithmic breakthrough. So in short, bigger model, more data, and more compute equal better AI. But scaling is not just about pulling one of these 3 levers harder and harder. It's really about orchestrating the 3 of them perfectly together. So for example, if you only rely on the model size and you only grow the model size, then what happens is overfitting. Essentially bigger models that memorizes a lot of noise because they don't have enough data to learn patterns from. On the other side, you can only optimize to have a lot of data and then ending up with underfitting. Essentially tons of data is useless if the model is too small to take the data and extract and generalize patterns inside the data. And then finally computing. If you only scale computing without enough data or with too little parameters in your model, then you just waste money and a lot of energy. But if you well balance these 3 and you scale them together, then you get a lot of improvements and predictable improvements. But so if scaling laws work so beautifully when balanced, can we actually just keep scaling forever? It feels like nothing can kind of grow forever. So are we running out of room and road to scale? Let's see what are the possible bottlenecks that there can be in scaling laws. The first is the data bottleneck. In fact, high quality human written data is actually not infinite. And indeed, the internet's clean text data or code is already being used heavily and it's kind of finishing. A lot of AI researcher experts, including Anthropic's CEO Dario Amodei, have a lot of consensus around the fact that we haven't fully hit the data wall thanks to synthetic data. In fact, solutions like self-play AlphaGo Zero, essentially the model playing AlphaGo against itself, or other solutions like chain of thoughts reflections, can and are creating new data, new valuable data that is very useful and is being used for training. So there is still enough runway to go, at least for now. But even if we are slowly running out of clean data, clean high quality and human written data, there is still distillation. Distillation can be another critical tool for survival, at least on the bottleneck of data. Essentially, distillations allow to have a bigger, very massively trained model, which is the teacher model, and use that to train a smaller model, which is a student model. The student model will try to mimic the teacher's model behavior and not limit itself at just copying raw data. And this matters a lot because instead of needing a lot of new tokens, real world tokens, real world data, you can extract a richer and denser value, denser learning materials and signals from the same amount of data, from the same tokens. So for example, instead of just learning that the next most likely word is cat, the student model will learn what is the exact probability that the next most likely word is cat, or what other words may fit well. It learns how to think and not just what to say. Essentially, it reuses existing tokens efficiently, more efficiently, and it can get denser and richer learnings on a per token basis compared to traditional models. So yeah, essentially distillation doesn't really need new data. It mines deeper and valuable gold from existing data. So I would say say we're absolutely good to go for the data bottleneck, at least for the moment. Now, the second potential bottleneck is actually scaling. Pre-training may plateau. Pre-training has been improving for a long time. Models get better and better as you increase compute. But there is a big debate and a big question about this curve that you can see now. Is this predictable curve actually gonna flatten out? Well, here is the catch. Even if pre-training scaling laws will plateau, and by the way, as of right now, there is no sign that that will actually happen, well, there is still a new and more exciting frontier that is opening for scaling laws. And that new frontier is test time compute. Essentially, instead of just making models bigger and better during pre-training, we can make them think harder and plan deeper when they are actually being used. In fact, the current models answer with just a few steps, but future models, well, they will be able to reflect, search, replan internally before answering much more than actual models that we're using now. And all of this during inference. It's like adding a second brain behind the scenes. And the cool thing about this is that we know right now that it works. In this image GPT 3.5 and GPT 4 that do perform better when they are allowed to think, reason, or reflect, or even plan. Huge increase in performance with the same exact model, just with reasoning, which is very cool. But one thing to note here is that scaling laws used to be much more simple than they are today. As we've seen, bigger model, more data, more compute, equal easy wins. But today the trade-offs are kind of different. But let's give some context. Let's go back to 2020. OpenAI released a new paper on scaling laws, and they made a simple bet. Just grow parameters, grow compute, and grow data, and the models will get better, predictably. And we've seen that. They did it, and it worked for a long time. But then Chinchilla happened. DeepMind showed us that earlier scaling laws were actually wasting some energy, wasting compute particularly. More data with a smaller model actually, if properly balanced, can actually outperform bigger and less efficient models. This was the first evolution, and it's what we said earlier about balancing the three pillars. It's when scaling became not just about bigger and bigger at all costs, but also bigger and balanced. But what about now? Well, today is a bit more complicated. In fact, labs today are not only optimizing for size during pre-training, but they're also heavily working on two new factors. The first is inference efficiency, which is how cheap you can run the model after training. How cheap and also how fast. And then they're also optimizing for context length performance. Essentially how much memory the model has and how good it is at using this memory, this short-term memory. And this matters a lot. For example, it matters very much for AI agents. Long context windows with good performance can allow your agent to handle very complex multi-step tasks and not lose the thread halfway through. And inference efficiency allows these agents to be deployed economically at scale. And that is exactly why labs are already optimizing for these two new factors, these two new dimensions. They are already sacrificing training efficiency today in exchange for a much cheaper and much more efficient inference tomorrow. If you want to know more about this, you can click this video here. But if we know now that the scaling game is changing drastically, what does that actually mean for you? What does it mean for the future of AI agents or any AI product? Well, if you think, for example, that today's AI products feel a bit clumsy, you are not wrong actually. But as scaling laws supercharge AI agents, I believe three things will actually come. The first is more steps of reasoning. Future agents won't just react. They will think, reflect, and plan multiple steps ahead, much better than they are able to do today. The second thing I believe will happen is memory-rich agents. 32,000, 128,000, why not even 1,000,000 tokens, context windows for your agent. That will allow agents to be extremely good at tracking complex tasks across long conversations, long projects, and long workflows. Massive improvements in performance. And the third thing I believe will happen is deeper planning with test time computing. That will allow AI agents to dynamically plan better, correct themselves mid-task, and adapt better. And what does this mean for anybody who's building an AI product or an AI agent? Well, if today's AI agents are like toddlers, reactive, clumsy, and forgetful, tomorrow's AI agent will actually feel much more like competent experts that are capable of reasoning and remembering stuff, and therefore autonomously take action. Yes, of course, they are kind of already doing this on a certain level, but in the future they will actually be able to do this on an extreme expert level. And all of this is baked into scaling laws. So what is very, very important to keep in mind, in my opinion, is that we should really build AI products knowing that these three factors will improve, and therefore we should build something that benefits of the improvement of these three factors, because AI labs are already optimizing so heavily on them. And also, I think we should build them now. Right now. Because if you think that this future is gonna happen 5 to 10 years from now, actually think again, because scaling laws are not slowing down at all. And actually, if improvement trends in AI hold, and scaling laws suggest that that is happening, and they will, we can really just extrapolate them into the future and realize that within 12 to 24 months, AI models could outperform human experts across a huge range of tasks. And this is really not science fiction. This is not even hype. This is just a straight line extrapolation from scaling curves. So, for example, instead of building simple chatbots, we should really think about building either AI agents or AI products that can reason, remember, and adapt over time. Products that grow stronger, not weaker, as AI capabilities scale. We should build on the assumption that agents will think deeper. Build on the assumption that the context windows will keep expanding, and build on the assumption that inference will get cheaper and faster. If we build with those three assumptions in mind, and if we build today, we can create products that feel like they were made for the world that is coming, not the world that is passing. And yes, scaling laws don't wait. We can't stop the wave. We can only choose whether we want to surf it or not. So yeah, let's build something for the world that is coming. Thank you very much for listening. Click here or here before the end of the video, and see you next time.